Guys, thank you for following along today when I couldn't be in. I appreciate it. So let's just take a look at these. We didn't have a chance to finish this up last class, so I just want to make sure we understand what's going on with this type of problem. And then after this, you'll complete your Delta Math assignment. So in this set of directions, it says determine whether the lines are parallel, perpendicular, or neither. So just as a reminder, if our lines are parallel, their slopes are going to be exactly the same. If they're perpendicular, we'll have opposite reciprocal slopes, and neither is anything else. So let's take a look at this first one. We need to first rewrite both of these equations into slope-intercept form. So that means we need to isolate the y variable in both of these situations. So I'm going to start over here. I'm going to subtract 2x from either side. That leaves me with a negative 7y equal to negative 2x subtract 42, and then divide everything by a negative 7. I'm left with y equals a positive 2/7 x plus 6. So my slope here is 2 over 7. Now over here, I'm going to do the same thing, except I just need to get y by itself. So I'm just going to divide everything by 4. That gives me y equal to a negative 7/4 x subtract 1/2. So notice my slope here is negative 7/4. So these two are neither opposite reciprocals, nor are they the same. So we write neither. Next up, we have y equals 3 and x equals negative 2. Whenever I have this situation, I like to just sketch out what's going on. So y equals 3 is a horizontal line going through where y equals 3, and x equals negative 2 is a vertical line going through where x equals negative 2. Notice I have a horizontal line and a vertical line, so these are always going to be perpendicular. All right, lastly, we have these two equations. So we have 2x plus 5y equals negative 1, and 10y equals a negative 4x subtract 20. I'm going to get y by itself, so I need to leave this expression here first and bring this 2x over to the other side. I have 5y equals a negative 2x subtract 1. Then I divide by 5 everywhere. And I get y equals a negative 2/5 x subtract 1/5. So my slope here is negative 2/5. In this situation, the only thing I need to do is divide by 10. So I have y equals a negative 4 over 10x subtract 2. So at first glance, it appears that I don't have the same slope, but you always want to make sure that your slope is simplified to lowest terms, because when I simplify this expression, I can divide each of these, both my numerator and my denominator, by 2. And so I can rewrite this as negative 2/5 x subtract 2. So since these two have the exact same slope, we know that these are parallel lines. So we have parallel for number 9, 8 was perpendicular, and neither for question number 7. This last question involves a parallelogram in the coordinate plane. So even though I don't have a coordinate plane here, I'm going to go ahead and just sketch one out. So I'm going to just do a little sketch just so I know where the ordered pairs are. And I have A is at 0, 2, so it's right here, that's A. B is at 3, 1, 2, 3, 4. C is at 2, 7. And D is at negative 1, 5. This is C and this is D. And we want to know if this is a parallelogram. Well, in order for this to be a parallelogram, all of my sides have to be parallel. So what I'm going to do is I'm going to check to see if sides AD are parallel to BC. And the way that I'm going to do that is by finding the slopes of these. And then if these two are parallel, then I'll check to see if CD is parallel to AB. So I'm going to start by finding the slope of AD. So I'm using these two ordered pairs. I'm going to do 5 subtract 2 divided by negative 1 subtract 0. That gives me 3 over negative 1, which yields a negative 3. I'm going to do the same thing here for BC. I have 7 subtract 4 over 2 subtract 1. That gives me 3 over 1. 7 subtract 4. Oh, 2 subtract 3. I knew I did something wrong. That gives me 3 over negative 1, which yields a negative 3. So notice that these two are parallel. So now I want to check and see if AB is parallel to CD. So now I'm going to go ahead and find the slope of AB. So I'm going to do 4 subtract 2 over 3 subtract 0, and I get 2 over 3. And then I'm going to find the slope of CD. So I'm going to do 5 subtract 7 over negative 1 subtract 2. That gives me a negative 2 over negative 3. So again, at first glance, it looks like they're not parallel because they're not the same. But remember, a negative divided by negative equals a positive. So these are parallel. So since my opposite sides of this parallelogram are all parallel, we can say that ABCD is a parallelogram. Yay.